I live here? I'm just seeing if I'm live here. So I was just going to work a few math problems and try out this live thing. I don't know if everybody can hear me or how this is working, but I'm going to go ahead and give this a shot. So here's my screen. I'm going to OneNote. So I got some trig problems to work. I'll probably work maybe 3 or 4, and just because this is my first live stream, just to see how this works. So I'll start with this one. I got this one off analyzemath.com. We're going to solve for h. So they give us the adjacent here, and they give us the height is h. So tan of theta is the actually, let's not use tan. Let's use, yes, let's use tangent. Sorry, tangent is the opposite, which is h over the adjacent. So theta here is this angle right here. So we'll say that tan of 18 degrees is h over 100 meters. So we can go 100 meters is tan 18 degrees, and that's times, and that equals h. So running that through the calculator, I could try the ink to math. Let me give the ink to math a try. So you want to know what tan of 18 degrees. Oh, I did it, but I didn't solve it. I thought I might solve it. I don't write the equation, but yeah, it doesn't solve it. I thought I'd solve it. So here, I'll just do it in my calculator. Make sure it's in degrees too. So I get 100 times 0.32 is approximately h. Yeah, this is an estimate right here. So ends up being that our h is about 32. I guess it would be meters. That's what they gave us right here. So yeah, that's h. So let me go down. I'm gonna find another trig problem. See if we can solve it. There's one. This is out of my book. I have a trig book here, or pre-calculus book. Here's one. Convert this, so for 142 degrees and 50 seconds, 2 decimal. Alright, so we're doing Um, so how I usually do this is, this looks like 142 degrees plus 50 minutes. And that's also 50 over 60 is what that would be. So yeah, 50. So to go to decimal, yeah, if you got 50 minutes, you just divide that by 60 and get your decimal. Yeah, so that's just like that. And so here, 50 divided by 60 ends up being like 142 plus 0.8. And so you would just get 142.833. And that's decimal. And then you could check online, check my answer if you want, with degrees, minutes, seconds, converter, calculator. Yeah. So if I put 142, and 60 minutes, and I'm using the rapidtables.com, and sorry, 50, yeah, and that's what that comes out to. So that's that one. Alright, so another one we can do, I'm just going to jump around here. This is my first practice live stream, and I'll try to be doing a little bit more problems here. So they tell us that they're saying cosine x equals 7 over 25. And so right here, they want us to find cosine x over 2. So we could do that. We'll use the half angle. So let me look up the half angle. So cheat sheet. And so right here, cosine, so cosine x over 2 is the same thing as plus or minus square root 1 minus cosine theta over 2. Oh, sorry, it's plus. Cosine is plus, sine is minus. So, and that's over 2. So, we need to find what quadrant this is in. So if I have a triangle that's like this, right? 725. I think that quadrant would be 1. That'd be Q1 right there. So your answer would be half of Q1. And oh wait, I'm sorry, I didn't give some information here. They gave some extra information here that we need to find the sign. So that extra information would be that x was in between this interval, 0 and pi over 2. So yeah, it's in Q2, right? Q1, quadrant 1. So half of quadrant 1 would still be positive for cosine, so we'll pick that value. And so you'll just say it's plus, and they already tell us what cosine is. And that's 7 over 25, and that's over 2. So we're going to do, right here, we have 25 over 25 plus 7 over 25, and then that's over 2. So we end up with square root of 32 over 25 times 2, which equals 32 over 50. Alright, I'll work one more. Since this is just a test, I hope it all worked out. I don't know, it might not even be working. So the last one here is find all solutions. So number 4 would be find all solutions to we're going to do cosine squared cosine, okay, here you go. It's cosine 2x cosine 2x equals cosine squared x plus 1, and so here we can do change this one. It's a double angle, so it's 1 minus 2 cosine squared x. I think I did that right. Let me see. Other way. Yeah, that's for sine. Hold on. It's 2 cosine x squared minus 1. And now that equals cosine squared x plus 1. You would subtract your cosine and add your 1. You end up with cosine squared x. I don't know if it'll work. Cosine squared x. would be 2. But here you get that cosine x equals plus or minus square root of 2. And we know that cosine right here is in between -1 and 1. Square root of 2 is greater than 1. So I guess there's let's see, no solution. Let me check that. And you can use Desmos to check it. So let me just try it in Desmos. So what you do in Desmos, just to check, let's see, check, and Desmos. So we have, so you just do one function, y equals cosine 2x, and then you do another function, it's like y1, and this other function would be the other side of the equation, which is cosine squared x plus 1. So we have cosine of 2x, and then cosine of x squared. Yeah, and so they don't. These two graphs, they don't intersect. So if you did it in Desmos, you'll see one of them is like up here. This is y2. The other one is on the axis, like that. I mean, my art isn't great here. That's why I do math, not art. Yeah, these two don't intersect, so that's the answer, no solution. So I'll try to put out some more videos like this of me solving some problems. And who knows, maybe if people start watching, I'll just start solving their problems if they have any. Maybe do some free tutoring here, help build up my channel. Well, thanks everybody for watching.